Welcome to The Explainer. We constantly hear the exact same narrative about electric vehicles. We just need more chargers. But today, we're going beyond the plug to look at the real state of EV infrastructure. We're actually going to skip right past those consumer driveway chargers and uncover the massive, truly game-changing leaps happening right now, specifically in heavy freight technology. It's a fascinating shift, and we're jumping right in. Here's our roadmap for today. 1. The global charging gap. 2. The megawatt charging evolution. 3. A real-world case study on California trucks. And 4. Overcoming the final roadblocks. Starting off with Section 1, the global charging gap, taking a look at worldwide passenger EV data. So, is our EV charging infrastructure actually growing fast enough to keep up with the vehicles hitting the road? We hear it all the time, right? This narrative that the grid is hopelessly lagging behind, the buyers are totally ready, but the plugs just aren't there. Well, the hard data from the 2024 HERE SPD EV Index tells a much more nuanced story. It turns out it's really not this uniform picture of doom and gloom. It's actually a fascinating story of localized surges, and yes, some surprising stagnation, depending entirely on where you look. Look at the contrast here. It's pretty stark. Over the past year, the United States grew its public charging power by a really solid 82%. But Europe's aggressive push for electrification completely outpaced the US, hitting a massive 115% growth over that exact same period. That 33 percentage point gap isn't just some minor statistical deviation or a rounding error. It really highlights a fundamentally different pace of infrastructure deployment across the Atlantic, which is driven by totally different incentives and regulatory environments. Actually, scratch that. It gets even wilder when you look within these continents themselves, because the disparities are just massive. In the US, Delaware surged from 15th place all the way to the #1 spot, driven heavily by their targeted investments in high-power charging. Meanwhile, states like Minnesota are hovering way down near the bottom. Over in Europe, Denmark leaped to first place, thanks mostly to aggressive government tax exemptions, while Ireland is lagging behind in 26th. So what does this tell us? It proves that geography and good intentions do not dictate infrastructure success. Aggressive, localized policy does. When local governments put their thumb on the scale with rebates, the infrastructure absolutely follows. Okay, moving on to Section 2, the megawatt charging evolution and the shift to heavy-duty freight. This is where the paradigm completely shifts. We're not talking about slightly faster passenger vehicle plugs anymore. The megawatt charging system, or MCS, is a brand new architecture that's currently moving into real-world commercial deployment. It literally allows a massive heavy-duty truck to recharge an enormous 200 to 600 kilowatt-hour battery with over 1 full megawatt of power. And the absolute kicker? It achieves this immense energy transfer entirely within a commercial driver's legally mandated 45-minute rest break. That specific time alignment is absolutely crucial. It's the magic key that makes electric freight genuinely viable for the logistics industry, keeping trucks moving and supply chains totally intact. If we look at Eco-Energetica's 2026 trends, we're moving entirely away from those isolated, slow plugs hidden behind a diner somewhere. Ultra-fast charging, we're talking pushing beyond 350 kilowatts and up to 600 kilowatts, is becoming the new baseline. And because of this massive power demand, we're seeing the rise of huge multi-stand charging hubs that function a lot more like high-tech commercial travel centers. Crucially, we're also shifting to charging as a service. This is a real game changer because logistics and fleet operators no longer have to moonlight as grid engineers, right? They don't take on massive upfront infrastructure risks. They simply buy the charging as a managed service, which fundamentally lowers the barrier to entry for zero-emission freight. Let's make this concrete. Section 3, a case study of California trucks along the Long Beach East LA corridor. To really ground this in reality, let's look at a massive zero-emissions truck depot project in the highly congested Long Beach to East LA corridor. According to a recent California Transportation Commission memo, this technology improved so breathtakingly fast that the developers had to completely rewrite their blueprints midstream. They originally planned to blanket the entire site with 107 low-power chargers, but thanks to the new megawatt architecture, they were able to amend the project to require just 14 high-power megawatt stalls and 6 standard ones. They literally slashed the physical footprint required in one of the absolute most expensive real estate markets in the country. And adopting this fundamentally superior technology didn't just save valuable real estate, it completely transformed the underlying economics. State budget tables reveal that this shift halved the construction and equipment costs. It dropped the total project cost by over $14.2 million. It's an incredibly rare scenario where deploying vastly better cutting-edge technology actually makes the infrastructure vastly cheaper to build from the ground up. But wait, here is the absolute craziest part of all this. Despite cutting the physical number of chargers from 107 down to just 20, this new megawatt architecture actually increases the daily truck throughput by 31%. In the logistics world, throughput is the ultimate metric. Because the power delivery is so incredibly fast, the exact same physical station can now handle up to 280 heavy-duty trucks a day, up from the initially projected 214. It is the ultimate example of doing exponentially more with less, proving once and for all that smarter grid design easily beats sheer volume.
Finally, Section 4, overcoming the final roadblocks and looking at the institutional hurdles to scaling.
So if the technology is definitively better, faster, and cheaper, why aren't these hubs on every highway tomorrow? Well, a recent Electrification Coalition report makes it abundantly clear. It's like a giant puzzle, and the primary hurdles are no longer technical. They are entirely institutional. We're battling high upfront vehicle costs that artificially limit initial fleet demand. We have incredibly complex program designs and massive bureaucratic delays just to get the physical connection to the grid. Add in electricity rate structures that simply aren't designed for how commercial trucks actually consume power, and you have a completely maddening maze of fragmented local permitting processes. Clearing these bottlenecks is going to require serious, coordinated utility reform, not just better batteries.
So, as we wrap up and look to the future of freight, I want you to consider this. The hardware has officially arrived. The chargers are fully ready to deliver a massive megawatt of power to revolutionize how our economy moves goods from coast to coast. But if the tech is ready and it's cheaper to deploy, will our grid, our utilities, and our policymakers actually be ready when thousands of trucks demand a megawatt all at exactly the same time? Something to think about. Thanks so much for joining me on this explainer, and I'll catch you next time.